Welcome, everyone. Slowly getting everybody in. We'll get started in just 1 minute. Welcome. Thank you for joining us. So, perfect. I know folks are going to continue to hop on the call today, but we're going to go ahead and get started because we have some great imagery to show you, and Court has some wonderful experiences to share with you and knowledge to share with you. So thank you all for joining us today, and welcome to the Monarch Conservation Webinar Series. Today's webinar is a journey through the monarch's winter home, the sights, sounds, and science of the migratory monarch butterfly colonies. Our presenter today is Court Whelan, Expedition Leader, MJV Board Member, and Chief Sustainability Officer at Natural Habitat Adventures. My name is Alyssa Taylor. I am the Online Education Manager at MJV, and I'm joined by my coworker who is behind the scenes, Jenna Tatz, who is our Senior Education Manager. She will be manning the chat and any technical needs that you might have today. But thank you all for joining us. We're super excited for a very timely webinar this month. We do want to begin by honoring the land on which we live and work. The offices of the Monarch Joint Venture are located in St. Paul and Belle Plaine, Minnesota, and we acknowledge that this land is the traditional homelands of the Dakota people, specifically the Mdewakanton Dakota, who have lived here for generations and continue to live here today. We recognize the enduring presence and contributions of the Dakota and the Ojibwe nations across Minnesota. You can use Native Land Digital, an Indigenous-led nonprofit organization, to see a digital map of Indigenous territories, languages, and treaties in your areas. We'd also like to thank all of our sponsors, including Monarch level sponsor Bear, for their support of MJV's virtual education, including this webinar series. If you or your company is interested in sponsoring this year or next year, please email learn@monarchjointventure.org. Now, before we get started, a few technical things. I'm sure most of you have been on our webinars, but a couple of reminders. If you have not registered for the webinar, and you'd like to receive all of the wonderful follow-up information, please make sure that you use the link that Jenna is putting in the chat to register so that we can capture your email address for our follow-ups. So please make sure to do that if you have not registered. This webinar, if you do have to leave early, will be recorded and posted likely by Friday, along with the other 11 years of Monarch Conservation Webinar Series topics. So please feel free to explore those as well. Today we will be using the Q&A box. That's where we'll be collating all of our questions. So as Court is presenting today, please make sure to put your questions in the Q&A and not the chat. We'll collate all of those and we'll have time at the end for today. We can't see you, although you can see us, but you can use reactions during the presentation. It's a fun way to interact with our speakers, so we will be able to see those, so feel free to use them as well. And lastly, we do have translated captions and captions on this call, so if you would like to add captions in a language other than English, you can click the arrow on the captions and the translation button to choose the appropriate language. And with that, lastly, our webinar speakers represent their own viewpoints, which are not necessarily those of the Monarch Joint Venture. And finally, before I turn it over, I want to introduce Court. Court has spent much of his youth outdoors fostering a strong love and appreciation for wildlife, which led him to attend the University of Florida, where he received his bachelor's, master's, and PhD degrees in both ecotourism and entomology. He was able to design his coursework, research, and teaching to focus on, as he puts it, conserving the world through nature and educational travel experiences. Today, and a couple hundred more expeditions later, Court continues to guide the world's best nature expeditions with Natural Habitat Adventures and the World Wildlife Fund, while also heading up NatHab's sustainability efforts as Chief Sustainability Officer, elevating it to become one of the most sustainable and eco-conscious travel enterprises in the world. He has also developed a keen sense for photography and videography, which you will see today, which has led to a true passion and profession as he now guides many photo expeditions each year to the world's most iconic areas and ecosystems. He cherishes his time teaching and extending his love of conservation, biology, and photography to anyone that is eager to learn. And with that, I am going to turn it over to Court.
Oh gosh. Well, thanks, Alyssa. Now I've got to follow that up and actually deliver. That was a beautiful intro. Thank you so much. I appreciate that. And thank you everyone in the audience for tuning in. I have to say, just by being here, you're doing one of the best things you can do, kind of your conservation superpower for the monarchs, in terms of understanding and the takeaways I'm going to be giving you today in terms of understanding the science and what's really going on with the monarch migration. So through the magic of technology, I'm going to go ahead and share my screen here. So bear with me a quick second, and we should be off and running. And yeah, there we go. Technology. So yeah, a journey through the monarch's winter home. So a little bit about me. Obviously, that was a lot about me, so I won't spend too much time. We want to focus more on the butterflies, but this is me and my element. I do wear a number of hats, but my primary focus is really conservation via travel. I believe that getting people out there to see experiences and understand the natural world, it kind of goes back to the idea that you cannot say what you do not love, and you cannot love what you do not know. There are many different ways to get to know things, and you're doing that right here today. But one of my most joyous pursuits, where I find a lot of awe and wonder in the world, is indeed out in nature, and with monarch butterflies on my head, like this photo. But I digress. So yeah, we're here for the monarch butterflies, right? And it's gonna be mostly a presentation focused on kind of their migratory phase. And to understand all this, I'm breaking the presentation down into several key questions. But before we start to question and then answer, we got to start from the very beginning. I know a lot of you have worked with monarch butterflies or are already familiar with them. This is just a really fun excuse to show a cool magnified view of a butterfly's wing, to show those kind of roof shingles, almost like Spanish tiles. This will come of importance later when we talk about some of their adaptations and talk about how they might resist wintertime conditions or even wintertime conditions in Mexico. But I think this is really fascinating. The monarch butterfly is, of course, part of the order of insects of the Lepidoptera, so they're very closely related to moths. They are more recently evolved. They evolved quite a bit sooner, still 65, roughly million years ago. But nevertheless, moths being evolved, somewhere around 160 to 200 million years ago. Fun fact, this is a good cocktail party fact. For every 14 species of moths we have in the world, we have one butterfly species. Just kind of a fun thing. So the moth diversity led to the butterfly diversity. And, of course, we have to talk about the life cycle. They are complete metamorphosizing insects. So they go through these dramatic changes in life stage. And I'm not going to belabor the point here. I want to make sure we save enough time for all the various wonders of the migration. But the key thing I wanted to get across here is that when we're talking about the migratory phase, there's no reproduction really involved in this part of the butterfly life cycle we're going to be talking about today. But nevertheless, one of the most miraculous things about the monarch and all these complete metamorphosizing insects is that they have two different body plans that are very, very suited to what they need to get done. You have one body plan and one type of animal, the caterpillar on the right, that is just a stomach with jaws. It's just an eating machine. And you may have heard before that from the time of egg to fully ready larva, they increase in size like 3,000 times. So they are just eating machines. Juxtapose that with the adult butterfly on the left, and these are moving machines and they're breeding machines. In the case of the monarch migration, they are flying machines. And so, what better way to be able to sense conspecifics or other monarch butterflies and get to them to mate and reproduce and get to the right areas and find the right plants to lay eggs than to be a winged creature like this that is able to subsist and last in various environments. Um, so milkweed is, of course, their host plant. We're not going to be talking much about milkweed today, except for the fact that it's one of the most important things you can do to conserve the monarch butterflies. But one thing to get kind of across here is that one of the reasons this monarch migration is so incredible, miraculous and wondrous is that this is not a food-driven migration necessarily. When they're going down to Mexico, they're not going there to feed. When we think about a lot of the other big migrations around the world that are just as spectacular in some ways, although this is the best, this is the best migration. Let's just get that on the table. When we think about wildebeest of Africa, whales going from Baja, California, up to the Beaufort Sea, when we, think about all the other critters that are migratory, other butterflies included, it's very much a chase of the food. But in this case, it's a chase of away from, well, I won't put the cart before the horse. It's to avoid the North American winter. We'll probably mention that a couple times. So again, the rest of the presentation is really going to be on the migration itself and talking about scenes like this and how they get into these massive, massive clusters of butterflies that are millions, if not tens of millions strong. So the first question of the presentation I'm going to attempt to answer is why do they migrate in the first place? I think that's a really kind of a very increasingly understood thing, but it's kind of an abstract thought, right? Like why did this butterfly all of a sudden decide to fly 3,000 miles in one direction and then turn around and fly back up north and have these leapfrog generations? Well, it goes back to this again sort of obscure idea that the monarch butterfly is a neotropical butterfly to begin with. So this is of course a blue morpho butterfly photographed in Costa Rica, but the monarch was tropical. It still is tropical. It still lives in a lot of its original range in the neotropics. In fact, the original monarch is believed to have evolved somewhere either in Costa Rica or, believe it or not, Panhandle of Florida. Those are sort of where the two likely areas are back when the temperatures were probably a little bit warmer. But nevertheless, what happened at some point in the last 10 or 20,000 years is something quite interesting as well. Is the ice age started to end more or less, and so what you had is this massive glacial sheet across half of North America, like half of the U.S., that started to recede. And if you've ever been to a place like Alaska or Patagonia or what have you, and you've seen a glacier receding, imagine a glacier multiple times taller and imagine it, many, many hundreds, if not thousands of times heavier. And it scarified the land. It roughed up the soil. It dug deep down and it essentially excavated half of North America. And what happened is at that time, again, we believe the migration probably originated somewhere around 20,000 years ago, is as that soil retracted and was scarified because of the weight of the glaciers moving north as they receded, as temperatures began to warm, we saw a huge preponderance and a speciation of milkweed, meaning milkweed started to diversify. We had more milkweed than ever before. And when we look at the number of milkweed species in Central and South America, that still to this day, resident monarchs rely upon and feed upon, you're looking at like kind of single digits of species of milkweed. But when you look at the rest of North America, when you think of, outside that tropics belt, we have over 100 species of milkweed. And so this really interesting thing happened is that, over the course of this time, this is one of the great mysteries that will probably never fully be answered because we don't have time machines yet. But at some point, those monarch butterflies, let's say two of them, four of them, some Noah's Ark version of monarch butterflies went up to test out the waters. There's this great saying in biology that nature abhors a vacuum. So as these milkweed plants speciated and as milkweeds really proliferated across North America, all where that red is the extensive milkweed. So it goes, a decent bit into Canada as well, is that you had all this milkweed and nothing was really eating it at that time. So again, the idea is that some intrepid couple or group of monarchs started to realize that, hey, there's this vacuum. Remember, nature abhors a vacuum. There's this untapped food resource that nothing is really eating in North America. But as they quickly found out, something else happens in North America. And around the fall and early winter every year, it gets snowy in many places, especially where milkweed grows in the summer. We see snow, we see freezing rain, we see ice. Going back to that first slide I showed you, they have these roof shingles on their bodies, these scales, which work really, really well to shed off water. They're actually quite hydrophobic. They are sort of oily and they will shed off water, but they don't do real well with like 0 degrees Fahrenheit. They don't do real well with freezing rain and snow. So this is again one of these things that is so wild to think of, and I don't know if we'll ever know for with absolute certainty. But basically, in that same year that these monarchs explored and found this treasure trove of food, all these milkweed plants, they then encountered winter, and they would have had to return back down to the tropics somewhere in order to bypass the North American winter, in order to essentially avoid this area that was too cold to hibernate and also coincidentally didn't have any food for them necessarily. So again, within 1, maybe 2 years max, they had to get out of Dodge. And now what we have is every single monarch butterfly east of the Rocky Mountains migrating down to central Mexico in this neovolcanic belt area. We're talking about tens of millions of butterflies flying from Maine, from Toronto, even eastern Colorado, and of course, Kansas and Iowa and Indiana, Minnesota, all the way down to this very small little concentrated area. We're not going to talk much about the Western population, but a very similar migration happens there. It's a shorter time period. When we're looking at the grand Eastern migration, we're probably talking about, at least in historic numbers, certainly hundreds of millions of butterflies. And historically in California, we're probably talking about thousands or hundreds of thousands of butterflies. So today, those numbers, unfortunately, in California are quite a bit lower, as they are in Mexico as well. But we'll get to those numbers in a second. But the idea is that the migration we're talking about here is virtually every single monarch butterfly east of the Rocky Mountains going down to this overwintering area. You see a few question marks around Florida and the Gulf states. At this point, we do know they actually migrate across the Gulf. In some cases, we don't know exactly how many, but a fellow grad student of mine got a grant to go study descending monarchs in the night on oil platforms, believe it or not. He actually got a grant to take a helicopter and get out there and spend multiple weeks out there. And he noticed in the peak migratory time, monarchs were actually landing on these oil platforms in the Gulf of Mexico. Now, what did they do before the oil platforms? Nobody really knows. But that might go back to that hydrophobic coating, those scales in the wings. On a calm night, they might be able to land on that body of water, rest up just enough to continue the migration. And in Florida, the reason there's some question marks is not only the route, but also there actually is a resident population in southern Florida. Not only does it not get snow and ice and freezing rain, but it also has milkweed plants throughout the course of the winter. So it kind of checks all the boxes. But I digress. Let's talk more about the migration, the overwintering areas. So this is kind of your classic scene of where you might look from the trails up into these massive towering colonies, these clusters of monarch butterflies, way up in these Oyamel fir trees, and it's something absolutely spectacular. And so what they're doing down here, again, they're avoiding North American winter. They don't have food. They certainly don't have anywhere near enough milkweed species or individual milkweed stems in the tropics to rely upon those. So they're in this kind of quasi hibernation. And the best thing that they can do is really remain relatively still. They, of course, fly around quite a bit. We'll talk about why that is in a second, or at least in a few slides. But they're essentially in this diapause. They turn off their reproductive organs. They divert that to what we call somatic maintenance, which is just a fancy way of saying the repair and regeneration of cells. And so another cool fun fact is the migratory monarch actually lives about 4 times as long as the non-migratory monarch. This is absolutely incredible. And from the looks of it, they're doing quite well in this photo. You'll see a close-up photo in a few slides, and it never ceases to amaze me that these butterflies that fly thousands and thousands of miles down to this small little colony area can look like they emerged from the chrysalis just the other day. It's absolutely spectacular. But the idea is they are in this quasi hibernation. They are active. They're not going into a full torpor or a full hibernation like a bear, especially like a ground squirrel would be. They are active. But we'll come back to that topic in a second. So we now know that they're going south, right? All these butterflies are dodging the North American winter, but where are they going exactly? I said Mexico, I said the neovolcanic belt, but let's talk about that a little bit further. So it's not that they're just going down south. It's not like they're migrating back to the general neotropics or the New World tropics. They're going to a very, very specific area, a very specific mountainous area. In fact, they go to elevations in and around 10, 11, even sometimes 12,000 feet. And it's quite literally and virtually a dot on the map when you think about where this location is. It's not the massive tract of area as all the tropics or even all of tropical Mexico. It's a very specific area. And so we found this out actually relatively recent in the grand scheme of things when we think about kind of science and discoveries. This was discovered in 1975, published the year later in National Geographic in this very iconic article. Well, I should have grabbed my copy. I actually have a copy of this, which is pretty cool, in kind of mint condition. Great monarch memorabilia. But it was discovered by these community citizen scientists, Catalina and Ken Brugger, as they sort of explored the backcountry of Mexico on this citizen science expedition to figure out where in the world are these butterflies going. I won't tell you the entire origin story because that could be a whole hour lecture on its own part. But essentially, through a program from Dr. Fred Urquhart, who was at University of Toronto in one of the original tagging programs, he, as well as many others, realized that monarchs just were disappearing after the summer. They'd be in huge numbers, but then after the summer and after the fall, there would be none. And through deduction and through some reasoning and whatnot, he figured they must be truly leaving. They're not going into like a underground chrysalis stage or overwintering as eggs or larvae like some other insects might do. He thought they were really leaving, and he started to think, well, there are monarchs that are residents in the tropics, so maybe they're going down south. And he put the feelers out as far and wide as he could. But lo and behold, long story short, Kathy and Ken Brugger, or Catalina Brugger, as her traditional name, found this little town of Ongungueo deep in the mountainsides of southern Mexico. And the cool part of the story here is not only is this the site, really the area of discovery after asking people, hey, have you seen things like this? And holding up a little Polaroid, little photo of monarch butterflies. And after going through probably what I can imagine to be dozens and dozens of these small, sleepy Mexican villages, they found this one that held the treasure trove of discovery. And this is Angungueo, the same place that I actually guide my trips out of. And this is a great kind of classic scene. The streets of Angangueo still remains very traditional, known as a Pueblo Mágico. It's kind of like an equivalent of a World Heritage Site. And it's just charming and lovely. And what's so cool is they've actually embraced monarch tourism in this really, really amazing way. You see murals and signs, and there's a lot of revenue that comes into the town because of butterfly ecotourism. And this is a huge thing to promote the conservation of the butterflies. We'll talk more about that in a few slides. But the idea is that indeed the monarchs were discovered by Western scientists. Local people have known about them for what I can only imagine to be hundreds, if not thousands of years. In fact, if you go to one of the pyramid sites outside of Mexico City in San Juan Teotihuacan, through a little bit of artistic impression on one of the frescoes of the walls in one of these outside palaces of the pyramids, you can actually see what looked to be people kind of frolicking and chasing monarch butterflies. You have to use a little bit of artist interpretation there, but it could be that people knew about this as far back as 2,000 years ago when the Teotihuacan Empire stretched across much of Mexico and present-day Mexico City. But anyway, I digress. The idea is that this is sort of the winter home. This is one of many town sites around the monarch butterflies, but it's not the only place. In fact, any given year, the monarchs occupy anywhere from 12 to up to 19 different colonies. So when we do our sort of measurements and our studies of what the overall butterfly numbers are from year to year, it's the summation of as many of these sites as have been discovered from year to year. But sometimes, science has found that there are small little patches of butterflies, maybe in the hundreds or thousands, that are on steep sides of volcanoes, Cerro Altamirano, or colonies that haven't been even discovered yet. But nevertheless, they are in multiple different sites. And so when I show you some of the following photos, these are kind of representative examples of what any of these sites might be like, because we're going after a few different things. I should say the butterflies are going after a few different things in terms of what they're looking for specifically. So here's just an image of hiking down the trails in the monarch butterfly colonies. It's a beautiful kind of old growth fir forest. We're surrounded by oyamel trees. It starts off with a little bit of walk, and then we ride a horseback ride, and the sort of the anticipation is building as we're getting in the kingdom of the monarchs, as we call it. We're getting close to the monarch sanctuaries. It's about an hour's hike slash horseback ride away, and then as we start to get close to the colony, we see one butterfly. And then we see two butterflies. They might be hanging on to the fir needles, they might be flying in the air. But then what we start to see is the clusters. And they don't look like much, to be honest. When you see this, oftentimes at first, when I point this out to groups and I'll say, hey, we're just starting to see the edge of the colony right now, just through those trees, people will say, that thing over there, it kind of looks like a lot of dead leaves. And it is funny because, from afar, the underside of the wings, that kind of cream color gives them this cryptic coloration. And who knows, that might have been a key to their survival in long past. Of course, their upper sides are brightly orange colored, but this underside does sort of look like dead leaves. Sounds like a great study for a grad student someday. As the light begins to shine on the trees and we peer through another set, we start to see wings slowly opening, and we notice that, oh gosh, no, this is definitely not a cluster of dead leaves. These are thousands, if not tens of thousands of monarch butterflies covering every single square inch of these oyamel fir trees. We get closer and closer. We might zoom in with a scope or with a camera with binoculars. We notice that these are just absolutely packing every single thing that we can see in the area when we look into the heart of the colony. It's absolutely extraordinary. On warmer days, we will start to see them getting active. And so this kind of flies in the face of this idea of hibernation, right? We think of them in this quasi hibernation, this torpor or this diapause, to throw out a bunch of fancy biological terms. So why in the world would they be flying? Well, it's quite interesting. So the idea is that when they're down here, they are not really feeding very much. Now they're drinking water, but they're not feeding very much. So they're really in this kind of energy conservation mode. And what we found is that when the sun shines through the colonies or when it shines in a certain patch of the trees, these butterflies, as a way to actually cool themselves down, is they soar through this mountain air. They glide. They're such efficient flyers. Not a surprise for a butterfly that, flies 3,000 miles and does quite well at it, but they're so efficient at flying that they actually cool themselves with convection of the cool mountain air. So that's one of the key things that they're looking for. They're actually looking for a very specific temperature down here in terms of the average between the lows and the highs, around 40 degrees Fahrenheit. So that's one of the things that they're looking for. They're actually looking to be cool. They don't want to be so cold that they're getting freezing rain and snow and getting bombarded with winds and winter storms like you might have in, say, North Carolina or in Illinois. But they're looking for this slightly cooler temperature to preserve their metabolism. If they get too hot, it actually burns up all the fats and lipids that they've stored in their bodies, really, from that southward migration. When they're tanking up on that nectar, they're feeding and feeding and feeding on their way down. When we get down here, they're not really feeding much, so they actually are active as a way of cooling down. For the majority of the season, they're not looking for a mate. They're not looking for flowers. They are trying to keep at a certain temperature and a few other things that I'll show you in a second. One of the really key ingredients that they're looking for is access to water. So we found through years of study that they're not feeding much. We estimate that about 5% of the population feeds over the course of the winter. We'll see lots of butterflies on the flowers, and we'll expect that this must be some sort of significant contribution, right? But only about 5% feed. However, just about every single butterfly has to drink water over the course of the winter. So we'll often see them puddling in mud puddles like this or on wet rocks. And this is one of the other unique areas of this region, is that there are a lot of freshwater mountain springs, and they emerge in puddles. They emerge in little creeks and little drainages. And so this gives them really great access to easy to drink water, right? And there are probably some salts and minerals in there as well. But probably the more important thing, or at least as important, is that this creates a microclimate. So you can imagine from previous photos, these towering trees that act like an umbrella over the forest as a bit of a forest canopy, with fresh water flowing here and there, kind of percolating out to the ground through springs, but also those trees holding in the humidity. So the other big thing that they're looking for is not just the coolness. They're not just looking for the altitude in tropical Mexico, again, to get that coolness mixed with no snow. You got to be high in the tropics to get that. But they're also looking for a relatively high humidity level. Okay, so now we're not going to really see it when we're down there. In the years I've been going, this was my 23rd season going down to the Monarchs. I've never on my skin felt necessarily a significantly higher humidity level, but if you take instruments out in the colonies, you'll find that it is actually really quite important. And it might be one of the biggest factors as to why they're here in the first place, because it gives them all the right ingredients. Monarchs, as well as most insects, they're really, really susceptible to being dried out from their exoskeleton. So they have to have that moisture around them. And it's really absolutely amazing. Another fascinating fun fact, if you think back to the slide, or at least my little spiel about the California population, and you're thinking, okay, you're doing the math in your head. Okay, Court says they're at 10, 11,000 feet. They're in the mountains of the tropics, and they're at, their high humidity level. How is that? Oh, and I should also say, and they're roosting on fir trees. How is it anything like the coastal California population that are roosting on eucalyptus trees? Well, if you take the average season temperature and the average season humidity level of coastal California and overlay that, map that with the average temperature and average humidity level of these monarch sanctuaries in Mexico, they're almost the exact same. Coastal California, high mountain volcanic Mexico, almost the same. Cool stuff there. Um, the next question, we're kind of bopping around here, but the next question you may be wondering, I've often wondered, is how in the world do they find their way? Okay, so they're looking for this very specific area. They went through this obvious, very interesting evolution. There were these intrepid butterflies that took a chance and then quickly found their way back home. How in the world do they do this with an insect that weighs less than a gram and a relatively short lifespan? Well, so as I mentioned, we're talking about everything east of the Rocky Mountains here. What they're doing is they're basically funneling down. They could be in Maine, they could be in the Dakotas, they could be in North Carolina, they could be in northern Texas. They're all funneling down for starters at a southwesterly direction. We'll start with that. What they're also doing in the fall is they're getting cues from the environment. So this is now the reciprocal time of year when they're actually migrating back north. But let's just put ourselves into the fall season. So that's August, September, October, that time of year, is they're getting cues from the environment. One is host plant senescence. The host plants begin to decay and die. That's an obvious one. Food is no longer there. That's a trigger for them. The other is that they're getting cues about temperature. It's cooling off. Okay, winter's coming. Got it. Check. The other is that they are very, very good at perceiving light and they can tell when the daylight nighttime discord shifts, meaning how many hours in the day are night versus how many hours in the day are actual daylight conditions. And once it hits a certain threshold, checks that box. And the final one, which is really quite bizarre, and to prove this, I've read this multiple times in the publications, but it's kind of mind-boggling, is that when they figure out, so they have very, very good circadian rhythms, and they can really tell angles of sunlight. When they can tell that the sun at noon is at 58 degrees above the horizon and not any higher, meaning winter's coming, the sun is a lower angle in the sky in the northern hemisphere. At that 58-degree mark, they know when that sun no longer rises above 58 degrees at noon, that's their final trigger, and then they enter migratory phase. So again, they're switching off their reproductive organs. They're no longer looking for a mate. They're diverting all that energy. Mating and breeding is energy intensive. They're shifting all that to just the repair of cells, and they're essentially quadrupling their lifespan. But then they're also becoming migratory and getting the cues from the environment of how to navigate. And so I mentioned, um, well, I'll talk about that in a second. Here, I just wanted to give you a close view of a monarch butterfly, just to show you how amazing it is. This is a butterfly that has flown thousands of miles, 2 to 3 thousand miles, very likely. I mean, it could be less, but we have on average probably, at least, 1,000 plus miles. And it's probably been through rain. It's been through wind. It's been huddling in the colony. It's been feeding it flowers. And it looks like it emerged out of the chrysalis yesterday. It's absolutely stunning. I mean, it's pretty phenomenal. This is what I want to talk about in terms of getting the nitty gritty. So I mentioned that at first they're going in a southwesterly direction. That's giving their initial compass heading and compass bearing. How are they doing that? Well, like I said, they have very, very good circadian rhythm and they have very good acuity as to where the sun should be based on what time of day. So just trust me when I say they have an internal time compensated sun compass. It's like they know where southwest is, where northeast is, just by being able to cue into their metaphorical wristwatch and where the sun is in the sky. And so, from numerous laboratory studies throughout the years, we figured out that they start out in a southwesterly direction. And you can imagine whether you're in Georgia or whether you're in Louisiana or you're in Tennessee, that gives you a pretty good starting point, right? Like if you start heading southwest, that's a pretty good starting point. And that gets you not all the way, of course, but a pretty good long ways there. They're also very good at picking up landmarks, and there's a lot of ideas that they probably follow volcanic ranges and all that. But what I want to talk about next is something that's been kind of debated in science for quite some years, and this idea that do butterflies have a magnetic sense? And so something I didn't talk about before, but this town of Ongangayo, this neovolcanic belt, a site of existing and past volcanoes, has a very huge magnetic anomaly. This little area has a very big magnetic anomaly. So researchers sought to figure this out as late as or as far back as 1985 or 86, I believe, trying to figure out, well, if can we determine if butterflies have some sort of magnetic sense? How salmon do, how sea turtles do, and how so many creatures that go long distances by looking at the banding of the Earth's magnetic field, et cetera, et cetera. Well, the study initially found that yes, they have magnetic sense. They actually sequester magnetite from milkweed. They sequester it and they actually position it at the base of their or at the base of their wings, and it actually acts like a little magnetic bar that tickles little sensory hairs in their wings. Yes, you can't make this stuff up. So they figured that out. They said yes, it does. And then I kid you not, probably five studies after that constantly ping pong between disproving and then reproving that, and then disproving it because they couldn't replicate it under similar laboratory conditions. That's the beauty of science, is that if you follow the same methodology and don't get the same findings, you can then publish something, which is great, but it causes a lot of confusion at times. But nevertheless, a really interesting study came out. I believe it was in 2019, still somewhat recent. Is that finally they figured out that yes, monarch butterflies do have magnetic sense, but only under a certain wavelength of light, only when exposed to 480 nanometers of light. And you might be wondering, what gives about that? Why only a certain amount of light? Well, it happens to be on the spectrum of light of sun shining through clouds. The light that makes it from the sun to the monarch eyeballs through clouds cues their magnetic sense. So that answers a question of how do they navigate on cloudy days. Now we've long since known that they can use polarized light, and of course, I'm sure that's a big part of the equation. But the idea of being able to turn on a magnetic sense when clouds are coming over is a pretty amazing finding. And I at least for now, is sort of put to rest this idea that do or do they not have magnetic sense. So we're kind of in a bit of a Russian nesting doll situation. The biggest funnel, the start of the funnel is the southwesterly direction from the time compensated sun compass. The next will be in conjunction with that, but also getting them closer to this very magnetic anomalous transvolcanic mountain. And then the final, we believe, is chemical cues like smell, basically. And the idea is that getting back to these scales, when they're in these big aggregations, when they're flying around to cool down, or when they're puddling at water, or just simply being in the trees, they're sloughing off scales. And these scales have a chemical signature to them that we know butterflies can perceive. In fact, some of that sense is how they find each other in order to mate. So when you see all these butterflies, not only the scales, but some of them don't make it throughout the course of the year. So the final way that we believe the great great grandchildren of the migration season before make it to almost the exact same trees as their ancestors comes down to sun, magnetism, and then chemical cues via scales and bodies of previous butterflies. You can imagine if you're an ancestor, and this is very primordial, if you're an ancestor and you can smell some sort of anomaly in terms of where your ancestors were the year before, the fact that you're there alive means your ancestors made it. So they did something right in some way. So the chemical cues from the scales are a really important thing. Okay. So what are they doing while hibernating in Mexico? So I've talked about this a bit, but really what they're trying to do is just kind of chill out. I guess literally chill out. They're trying to keep it a relatively cool temperature. They like to be in the shade. They like to be drooping from these fur clusters. They like to be around other butterflies. They're not necessarily gregarious in the sense that they follow one another. We believe this is probably mostly due to strength in numbers for predation, which we'll get to in a second. But the other thing that they start to do, as I mentioned already, is that, even though they prefer the shaded spots of the colonies, the sun moves across the sky over the course of the season, and trees are circular, right? So some part of your tree is likely going to get sun at some point during the day, unless you just chose a really, really deep shaded part of the colony, which of course they try to, but they're not always successful with. They will move from tree to tree quite often throughout the season. And on any given day, we could see a relocation event where a number of butterflies are truly picking up, flying, soaring through the air, cooling down, and landing in a shady spot in the latter part of the day. You can see here some images of, how light and dark the colonies really are. In fact, this is one of the most challenging things for photography, is that you have these huge bright spots and huge shaded parts of the colony. But nevertheless, they're trying to find a cool, shady part of the trees. They're also trying to get protected from winter storms. And I had to throw in this slide because you can't quite see it, but this was actually a few years ago when it snowed in Mexico. I was actually down there for a snow, which is very, very rare. But we do believe that the monarchs being huddled together might be further protection. If you're an inside monarch or a monarch below, you might have a little bit more protection from rain, from snow even, and of course, mildly freezing temperatures if it gets down to that. So they are trying to ultimately protect themselves throughout the course of the winter. Another thing they're doing is they are nectaring a bit. Like I mentioned, this is the minority of the population, but if you go down there and see it or have seen it yourself, you'll notice that they are on flowers. You see so many hundreds, if not thousands, on flowers. You're scratching your head the whole time, and you're like, how many more butterflies are there if this is only a fraction of the population? Well, it's a lot of butterflies. They're also trying to avoid being eaten. This is a rare shot I took several years ago of a black-headed grosbeak, one of the two species that actually predate upon the monarch butterflies. In fact, I have not seen many other photos out there of this. So, yeah, if anybody needs it for a presentation, let me know. Happy to share. But yeah, nevertheless, there are two species of birds that actually predate on the monarchs. One of the big benefits of the milkweed is, of course, that it's very toxic, and the butterflies sequester not just the magnetite, but they also sequester this toxin that's in the milkweed. But these are the only two birds known to actually be able to predate and eat the monarch butterflies. And between these two species and a species of mouse that actually forages on the forest floor, they account for up to 10 to 15% annual mortality, believe it or not, in the colonies year to year just from this predation. So just like I mentioned, nature abhorring the vacuum of the milkweed in North America when they first made that trial run from the top tropics to get that milkweed, these birds have figured out their own way around the chemical defenses that the monarchs have, and they quite literally have a buffet of monarchs in front of them, and so they do account for some significant predation over the course of the season. Like I mentioned, they are puddling, so they are drinking water, small sips. They're getting salts and nutrients. The males especially need these salts and minerals in order to form their spermatheca or their sperm sac for when they do mate again in the spring. And they're flying through the air. They're flying through the air for that convection, like I mentioned, that convection ability to cool down. Um, but I think one of maybe they're just trying to put on a show for us as well. They're trying to be part of this. I've heard there's a silly thing in wildlife biology when, everybody's kind of coming up with these names for what a group of animals is. It started with kind of the murder of crows, which is very, ominous and interesting. And then, crash of rhinos. And I've heard a circus of puffins. And what I've heard here is it's a kaleidoscope of butterflies. Um, they're also, whether they know it or not, they're actually contributing to science. And I don't know if you can see the anomaly in this photo, but if you look right here, this is from last year. I took a photo of a cluster of monarchs, zoomed in after the fact, and actually found one of the tags on the monarch butterflies, was able to zoom in even further. Thank goodness for Canon technology. Thank you, Canon Systems. I was able to read the serial number, report it to Monarch Watch. We could actually track this butterfly across North America. I think it originated somewhere in Ohio at the time, and we were able to notify the person that put on that tag. And we actually were able to connect and talk on that. So you never know of all the discovery down in these areas. You never know what's going to surprise you from year to year because again, at that time it was my 21st or 22nd year of leading these trips and studying the monarch, and this is my first tag I've ever found. And then the other thing that they're doing is they're leaving. Come the middle to second third week of March rather, second or third week of March, you will probably have very few monarchs remaining in the colonies, and it'll go back to kind of just this Oyamel fir forest that looks like a lot of other fir forests in the world. And so it's this a magical transformation throughout the course of this time period, roughly November to again middle of March is this magical time to be with the monarchs. Um, so this is exciting news. I feel like many of you, having signed up for this webinar, probably follow Monarch News. But talking a little bit about conservation, we have a rebound from the last 2 years. So last 2 years ago, unfortunately, was one of the all-time lows of the monarch numbers. Last year, it nearly doubled, and then this year, it's a 64% increase from the previous year. So the 2025-2026 season, remember, they're there from November to March, same individual butterflies, 64% increase. And then from the previous year to the year before that, it was almost double. So we do have an increase in population, but probably the first thing you're going to notice here is a very downward trend line. You're also going to notice a little red line up there that's right around the 6 hectare mark. And what that means is that's sort of the minimum viable population that we feel in science is enough to sustain the population long term. That was a mouthful, but in other words, that's our target. We're trying to get from what is 2.93 hectares, or about 7.24 acres. Hectares, like roughly 2.5 acres, more or less. It's the metric version. We're looking for about 6 hectares for long-term viability. So we have some challenges ahead of us. The population is down. I can certainly tell the decrease from when I started going again on the left side of the graph. But I can say it's no less spectacular. I can certainly say that. And as I round up my final few slides, I want to end with some optimism as to why, even though we have that downward trend, and any given year we can see a decrease in population. We were just very lucky in the last few days to see that increase. But I remain optimistic for a number of reasons, that the monarch is going to be able to be saved and be conserved for generations to come. Not just monarch generations, but human generations, decades, centuries to come. One is that we've been able to problem solve pretty good and be able to figure out what is their limiting factor. For a while, deforestation in Mexico was one of the big issues. And through the work of folks like MJV and particularly World Wildlife Fund and other NGOs, they've been able to reforest in massive scale. So when you think that they might be losing dozens of acres of prime monarch habitat and forest each year, there was a point where we were worried what's going to happen when the last tree is cut. Fortunately, we didn't get to that point, and to date, since 2020, or sorry, since 2013, over 20 million trees have been replanted in the monarch biosphere reserves. I'll say that again: 20 million trees have been reforested to rejuvenate the forest and reforest the entire area, and it's an amazing, amazing program. So we can problem solve, we can do things, we can enable people, we can empower people, and we can turn things around. In addition, the idea of ecotourism, or as what we call in academia now, conservation travel, is generating a huge amount of money for local economies. In fact, what it's showing is that butterflies and their trees are worth tens, if not hundreds of times more alive and well than dead or degraded ecosystem, meaning that tree has a single value when it is used for lumber, when it's used to make furniture or firewood or shipped off somewhere. It has a value. And a lot of these people are living in rural conditions and they have to put food on their table. But ecotourism, aka conservation travel, is giving these people significantly more money, which turns into better health care, more education for their children, better progress as a society by keeping the forest just alive and well for its own sake. There are some amazing organizations, amazing initiatives. I want to make sure I save time for questions, so I won't spend too much longer on this. But there are some incredible things being done. I will spend a few seconds on this because Monarch Joint Venture is, of course, one of the real leaders in monarch conservation. And it was funny. I was trying to pick a slide to represent Monarch Joint Venture and the monarch research and the programs. And I was like, I could add 70 slides to this presentation because of all the different things Monarch Joint Venture is doing to protect monarch habitat, to save monarchs in the adult form, in the larval form, the new technologies, the science. It's simply incredible. It really is. And as a board member, I'm so proud to be involved in what little way I can contribute to this amazing organization. But if you haven't checked it out, certainly look at the About Us and the programs. It's just nothing short of awe-inspiring. This is a silly one, but Google monarch butterfly and hit images. Scroll through the pages. You're going to see more fandom, more support, more love of monarch butterflies than just about any other insect. And really, it competes a lot with things like pandas and tigers, to be totally honest. It's one of the most charismatic animals in the world. And I think that we often get caught up in science with conservation science, that is, with trying to kind of justify ecosystem services from species. And what I mean by that is kind of talking about, well, monarchs, they're great pollinators, and they are food for invertebrates. Invertebrates can eat them. They do this and they do that, but at the end of the day, you just start to pay attention to how many people like yourselves love monarch butterflies. And I think there's a beauty to be said about saving something just because there's so much love around it. This is just an awesome thing. And fortunately, people are doing something about it. People are talking about it. There are journalists getting down to see the migration and talking about massive initiatives and writing publications in big magazines like the New Yorker. There are books coming out on the monarch migration. Um, by this guy. And you just have this unequivocal love for this small but incredibly mighty and incredibly awe-inspiring creature. Um, and so with that, I hope you learned something. I hope you enjoyed. We do have time for questions. I want to mention this not because I'm trying to sell a trip hard, but inevitably we get questions about this. I do guide trips. There is a way to get down to there to see this on your own, and we actually have two Monarch Joint Venture travel program trips to see the overwintering phenomenon, the very same itineraries that I guide. Not sure if I'll be guiding on these, so disclaimer, but our expedition leaders down there are absolutely fabulous, and we have a few spots left, I believe, on the second departure, but we're almost sold out for this coming season. So if you want to inquire about that, it goes back to the you can't save what you don't love, and you can't love what you don't know. You know a lot, you love a lot, but I guarantee you, seeing the phenomenon in person in the flesh is going to take that love and passion and awareness and drive to a whole nother level. So with that, I thank you, and I will happily take questions, and I'll stop sharing my screen.
Wait, before you stop sharing your screen, I kind of want you to go back to a particular slide because there was a question on it. So I'm gonna
Sure.
ask this first. So
Yeah, yeah.
firstly, thank you to Court for sharing one, his fantastic photography and skills with us, as well as this amazing presentation. Um, we do have quite a few questions. I'm going to preface with the fact, as always, that we will never answer all of the questions at one time, but we will follow up typically with our speakers and try and get as many questions answered as possible for you. So I'm going to start before you stop sharing your screen because there was two questions on
Sure.
the slide at the very beginning
Cool.
with the
Okay.
milkweed. If you could share what species of milkweed were on that slide.
Oh, you're going to really test me here. So, there are 36-ish common species of milkweeds that the butterflies routinely feed on. I mentioned that across the whole spectrum, there's like over 100, at least at one time there were. But as far as like ornamentals and things you can get from seeds, I'm gonna guess. Let me actually. It's like 70 slides, so I'm just gonna get out of this real quick. I'm gonna keep screen sharing, but we're going to go over here and yeah, I'm going to short answer and say this is tuberosa. This is probably incarnata, but I don't really know. But this is something where I highly recommend contacting MJV to get more resources. I will say we all have conservation superpowers. Um, I love guiding. I love talking about monarchs. I do not have a green thumb. I've tried. I really have. So I'm not probably not your expert in plant ID on this as far as milkweeds. Sorry.
Oh no, it's fine. Also, I think we've got showy, butterfly weed, common, and incarnata maybe, or swamp or rose milkweed.
Yeah, that's what
We'll
I'm thinking.
we'll get that photo and we'll put it in the follow-up email too, just because we did have a couple of questions on it. But I'm pretty sure
Sure.
that's what we've got sitting on there for now. Um, so great photos as always. So that was specific to that. I do want to knock out a couple of quick questions because you mentioned it at the end there. There were some folks that did inquire if you could tell them more about the tours and how they go about
Oh,
doing
sure.
that, signing up, or what that potentially would look like.
Yeah,
As
absolutely.
well as just one follow-up of just somebody inquiring about are the tours adverse or interruptive to the monarch's overwintering process, and
Mhm.
how that works?
Yeah, I'll lead with that, and I'll keep my screen on here for just a minute so folks that are inquiring can jot down the email. I believe everyone's going to get an email after this, and we'll have links and all that. Are they? adverse to monarch butterflies? Short answer, no. In fact, that was a big part of my dissertation is to figure that out. Flash photography, noise, disruptance. I did extensive literature review on, erosion and trail conditions and all that. And I will say, like anything in tourism, like anything in life, there will be nothing that has zero impact. When I go walk to the mailbox, I'm stepping on mycelium, which is disrupting soil composition. It's not much, but we always have some sort of impact. So I would be remiss if I said it had zero, but everything we do has something. The key thing, and this is the important part, is that you always have to focus on being net positive. Like, how do you significantly have more benefit than any sort of negative impacts you cause? And I think that's a really key thing when we think of the monarch tourism, because if it weren't for tourism, frankly, there's a halfway decent chance these forests wouldn't exist. And unfortunately, big caveat, unfortunately, that's where we're at in the world, whether we're looking at rhinos or elephants or tigers or monarch butterflies, is that the alternative, if we don't incentivize local stakeholders that are often needing to put food on their tables, and they may not understand the miracle of the monarch butterfly. They may not have a deep appreciation for it, but it's generating that money that the pros far outweigh the cons. But I'm happy to say, truly, there are almost no impacts. Flash photography, even though we don't allow flash photography just to be safe, very, very minimal impact. Sound, like almost no impact. They do have hearing organs, but almost no impact. And although we try to be, not just in our groups, but collectively, very quiet and peaceful in the sanctuaries, and we don't use flash photography because it'll disturb others, and we don't want to, miss of studying something about those things. So we don't do that, but fortunately, almost no impacts.
Awesome. Thank you. And then we'll include information as well in the follow-up email with those contacts if you missed that information also. Um, Two questions actually on your camera and your photography. What kind of camera do you use and what lens was used for the one with the tag?
Yeah, yeah, yeah. So my go-to lens, first of all, for monarchs, is a 100 to 500 lens. So contrary to popular belief, like a wide angle is not necessarily your best friend for monarchs. People might think like, oh, we're just gonna be around butterflies, so I don't need much telephoto. But to get these zoomed in shots, even like the one in my background, yes, we're close, but you want to fill the frame with them. That makes that big impact. So yeah, something between like a 300 and 500 mil lens, and I use a full frame Canon camera called the R5. I've just been doing this for long enough that I've upgraded and upgraded. But yeah, full frame is always my choice. It is kind of low light in some cases. And you also want to have fast shutter speeds to be able to freeze motion and all that. So full frame helps with those things.
Awesome. Thank you. Can you describe a little bit more about what is happening in their bodies when the cue to shift to migration mode?
Yeah, so that's another one that could be like a full hour, but it's essentially a genetic transformation. So here's the crazy thing is that all monarchs have the genome to become migratory, and it gets into like the way genes are expressed and alleles and like heterogeny and like some really complex stuff. But essentially, it's like switching tracks on a train in some ways, is that like both tracks exist, but it's what's going through their perceptive mechanisms, i.e., their eyes, their antennae, maybe tactily like their body, to shift those genetics over to express, meaning those genes to actually code for proteins that do a certain thing in the body. This is all like beneath the surface. Like we're not seeing anything differently. So they have both those tracks genetically, and you can actually induce migration. This is how we know a lot of this stuff, is you can induce migration from non-migratory monarchs by putting them in certain daylight, night conditions, by subjecting them to certain sunlight conditions and the angle of the sun and all that. So you can induce migration, but it comes down to a very, very complicated genetic level. I hope that's enough.
It's a great answer. Um, you had mentioned what are the two bird species that prey on monarchs or the with some of the photos that you had taken?
Yeah, black-headed grosbeak and black-backed oriole. Yeah, so it's a grosbeak and an oriole, and they both, again, this is weird, and there might be a publication out there about it, but they're both black and orange. Like maybe they're good hunters. Maybe it's just a little bit of camouflage, but I find that so fascinating. The mouse that predates upon them, totally different strategy. It's called a black-eared mouse, and it rose to the forest floor, and it basically feeds on monarchs that have fallen. Maybe a big gust of wind went through, maybe they lost their grip, and what happens is they fall to the forest floor, and then they're too cool to take flight again. Remember, insects are cold-blooded, so they have to have a certain amount of warmth in their body to fly. And so this is one of the most common questions when we're down there is like, well, why are these butterflies, at lower levels on the branches trying to fly again? Why are they down here in the first place? I see this butterfly quivering. Why is it doing that? Well, it's trying to warm up its flight muscles to then fly, regain its place in the colony, primarily to avoid frost on the forest floor, which might do them in overnight because sometimes it gets below freezing. But then also primarily it's a nocturnal mouse that just goes to town on these things.
Um, this is kind of in reference to some of the oil melt fir and the plantings in the overwintering sites. Do you know about how much area is planted per year and how long the firs take to mature?
Yeah, so these are pretty typical fir trees. So they have, they reach maturity, like maturity, like climax forest type maturity, probably in about like 80 years more or less. But that doesn't mean they're not still productive in the meantime. So yeah, I mean, of course they're smaller trees at this point, but we still see butterflies on those. And I should say the part that was like intensively logged was never like the exact trees that the butterflies were roosting on from year to year. Small asterisk to this, that did happen in a couple smaller satellite colonies, but unknowingly. But for the big colonies, I said there's like 12 to 14 to 19 in a given year. Like the biggest slice of the pie, like imagine a Pac-Man, like most of the pie is by like two or three different colonies, and those have been relatively well protected. In terms of total acreage each year, I don't know, but they're planting on average probably like, gosh, 1 million a year. So if you kind of just do some back and napkin math, like they have to be spaced at a certain point, and then after 5 years and 10 years, 15 years, they have to be thinned, in order for the healthy ones to take hold and not space, not have spacing issues. I don't know. It's a great question though. We can certainly look that up and get back to you.
Yeah, we can definitely add that into the mix too for our follow-up. I'm also recognizing we're at the top of the hour, but I want to end with one last question. I know there's a ton of questions we didn't get to. The good news is we're compiling resources to answer some of these. So look for that follow-up email. So I do want to remind you all, if you didn't register, to use that link that Jenna popped in at the beginning, and she'll pop it in now to make sure that you get that follow-up so we can get some of these questions answered for you. But the last question I want to hand off to Court, and I'm going to shout out to Valerie Van, who joined you on a trip last year. She wanted to know, have the Monarchs left Mexico and headed north yet?
Yes, they have. They have. I don't know if like every single monarch has left, but we're at the time of year where, what is this, the 24th? Like I would imagine the vast majority have left. Again, like the first monarchs historically take off, sometime around like again second, like let's just say like March 15th or something like that. But then it's a bit of like, they don't all take off from one day to the next. But by now, I'd imagine most of them have been gone. I've definitely been following the migration back north, and that's, following MJV on social is a really cool way. Something we didn't get to, but is a fascinating topic is these new Bluetooth remote transmitters. I talked about the tag, and that's been the best technology we've had to date. But in the last couple of years, we've been able to place, and I say I haven't placed any, but MJV and others, little like size of a grain of rice Bluetooth transmitters on the backs of Monarchs that actually ping signals to cell phones that have an app downloaded to them, and you can track the sightings without actually having to capture the butterfly, without being lucky and just like using binoculars to see the serial number. And so we're tracking these things in real time, and when we might have gotten two, three, maybe four data points per monarch, we're now getting like dozens, if not hundreds. And we're not just finding out point A to point B, like this colony in Mexico to this submarine ground. It's like this is the exact arc they're taking because there's 10, 20. Wouldn't you say, Alyssa? There's like 10 or 20 data points per monarch. Like it's just staggering.
Yeah, Jenna just dropped a link in the chat, and thank you all for hanging on with us. But Jenna dropped a link in the chat about this new tech, and you can really follow this migration. There's definitely monarchs on the move right now from the colonies reaching points in the southern U.S. So it's definitely happening. Migration is on the move in both the eastern and the western population. So I encourage you to check out that link that Jenna dropped. I encourage you to cite your observations in Journey North too. So there's lots of great community science projects to think about as we're seeing monarchs throughout that help us understand where they are throughout the year. So I definitely encourage you all to do that. I do want to give one last shout out to Court for sharing everything with us today. Um, Jenna also dropped in the chat a form for you. We'd love to get your feedback on all of our webinars as you join us. It helps us better offer webinars in the future and understand what topics you want to hear about. But for next month in April, on Tuesday, April 28th, we are going to have this will answer all of your milkweed questions. Milkweed biodiversity, exceptional plants, and natural history. We'll be joined by Dr. Anurag Agarwal, from professor of ecology and evolutionary biology out of Cornell University. So be sure to join us next month at the end of the month. And thank you again, Court, and thank you all for joining us. I hope you all have a great rest of your day.
Thank you all.